Brunetti, and I know that Bruno does not need much introduction to many of you, but for those of you who don't know Bruno, I'm going to let you know that he is a full professor of general and inorganic chemistry and president of the Center of Excellence, which is of SMAArt, which is scientific methodologies applied to archaeology and art at the University of Perugia in Italy, which he describes well as being equidistant from Rome and Florence. He is widely published in the scientific literature in chemical kinetics and, as many of us know, in cultural heritage science. He was the co-editor of the special issue of Accounts of Chemical Research, which gets a lot of citations because of the well-chosen papers there. And from 2000 to 2004, he was the coordinator of the European Network Labs Tech. And from 2004 to 2009, he was coordinator of the European Integrated Infrastructure Initiative, EURTEC. And many of you will be familiar with the volumes that came out as the product of the workshops on specific artists' materials and painting methods and materials, which are very beautiful and very useful. Between 2005 and 2009, he was responsible for the Perugia unit in the European project EPSCON, European PhD in Science for Conservation. And today he is the coordinator of the project Charisma, which many of you know very well and has tentacles spreading out into many areas and is tremendously valuable in providing support for looking at works of art. And he's going to talk a little bit about that now, and much of the work that he's going to present has been done with Costanza Miliani and Antonio Sgamolotti, also people well known to us. So, thank you, Bruno.
Thank you very much. Can you hear me? I want to start my presentation saying that almost all the data that I will present today have been obtained inside the activities of the project Charisma that consists of a consortium of 22 research institutions in Europe that are developing together different kinds of activities that are activities of networking, transnational access, and joint research. I have no time to enter into the details of the project that is quite big, large, and costly. I just say that the core of the project stays in the transnational access program. And the transnational access means that the European researchers can ask to Charisma to have access to the facilities that are belonging to the group of institutions of the consortium. There are facilities and competencies in terms of archives, for example, and so the European researcher, after an application, can ask to go and visit and consult the archives of the situ RMF that is located in Paris in the Palais du Louvre, or in London at the British Museum and the National Gallery, or in Firenze, the archives of the Opificio delle Pietre Dure, or Prado, the archive of the Prado Museum in Spain, in Madrid, and also the archives of the RCE that is located just in front of the Rijksmuseum in Amsterdam. But the user can ask also access to large-scale facilities such as the Budapest Neutron Center, or to the Synchrotron Soleil in Paris, or to Accelerator Aglaé that is located just in the Palais du Louvre, in the basement. Or can ask access to a small facility that has the advantage to be mobile. This means that this facility can be requested by a user that makes the application, and if the application is considered scientifically sound by an international peer review committee, the user receives the mobile laboratory in the same site where he is working. And this service is offered by 3 institutions that are the University of Perugia, to which I belong, the one laboratory of the Consiglio Nazionale delle Ricerche, one of the French CNRS. The instrumentation that is moved on site and is belonging to Molab is consists of substantially spectroscopy equipment. The measurements that are carried out inside are all non-invasive, that is without any contact with the surface that is examined. And for this reason, they are almost all based on the interaction between the light and the matter. So spectroscopy techniques are X-ray fluorescence, Raman, mid and near infrared spectroscopy, X-ray diffraction, ultraviolet visible absorption, ultraviolet visible emission, wavelength result, and also time with the measurements of the time decay as by point analysis, but analogous to the techniques that has been described before by Austin Nevin in his intervention. And I will talk substantially of these spectroscopy techniques, but before, just to give you an idea of how Molab is working, this is Molab just arrived at the Museum Boijmans van Beuningen in Rotterdam. You can see all the instrumentation is in various boxes, and the laboratory is assembled, putting together the various parts and the various components of the equipment. And the institution that is waiting Molab is preparing special rooms. Like in this case, we are in the National Gallery of Ireland, where we have been called to study a large painting, 5 meters per 3 meters, painted by Daniel MacLeese, that is an Irish painter, not very well known outside Ireland, but very important from the art history of that country. And you can see Molab here working on the huge painting on scaffoldings, also in some uncomfortable conditions. What I will do is to talk now about the limitation of the portable instruments and also the inconveniences that you have in working in situ. I will compare some of the techniques that are offered through Molabs, and I will show you some examples of how the integration of different techniques can lead to satisfactory results in identification of various substances. And I will show you also how it is relevant to carry out preliminary work in the laboratory before to go outside and carry out the measurements in situ. And then I will say something concerning the perspectives. I'm sure that you all have very clear ideas of the fact that passing from benchtop instrumentation to the work in situ with portable equipment implies loss of performances and inconveniences. For example, talking about Raman spectroscopy, you have no confocal setup, and this implies that you have a lot of fluorescence from the matrix. The optical path of the small instrument is reduced, and this implies a smaller spectral range, and the resolution is also lower. And then usually there are no shields for the daylight, so you have to carry out measurements in dark rooms for the Raman. And you have to pay attention to the risk for photothermal bleaching, because you are using artworks that are very precious in value, like in this case, for example. And you have to pay attention if you are working on scaffoldings, as I have shown before, to the vibration of the system. The various inconveniences are shown by Raman, but inconveniences are also shown by other techniques. And here I have reported a table where you can see the various instrumental restrictions for the 3 spectroscopy techniques that are more useful, more frequently used by Raman. X-ray fluorescence does not appear because I'm sure that you know everything concerning X-ray fluorescence. That is quite a standard technique and works always very well. And so Raman shows some instrumental restrictions, smaller range, and worse spectral and spatial resolution with respect to benchtop instrumentation. Also, X-ray diffraction offers a smaller range for the angular detection and the worst spectral resolution. Among the various instrumental restrictions, the lowest are those of FTIR that is available today in portable instrumentation that offer performances that are close to those of standard instrument for the laboratory. The time of measurements is very important for Molab because you have to optimize the time and the intervention that you are carrying out in situ. And you can see that FTIR is again a good advantage of implying low time to carry out measurements. Raman is still acceptable, but X-ray diffraction is a disaster because to carry out the measurements by X-ray diffraction, you need at least 20 minutes in the optimistic cases. But believe me, also these 30 minutes that are reported here is low. You need even much more if you want to obtain a very good spectrum. And matrix effects are present. And so for FTIR, you have matrix effects, but if you want to skip some interferences, you can use of combination bands, and so at the end you can solve the problem. But Raman gives a lot of fluorescence from the medium, and X-ray diffraction has shown not large inconveniences, but if you have extenders like Biacca, for example, distributed all over the surface, the signal could be definitely decreased by the presence of lead that is distributed to the surface that you are observing. And talking about spectral distortion, here infrared is terrible because there are a lot of distortion due to the fact that you have two reflections, the specular and the diffuse reflection. And according to the different rugosity, you have different percentages of the two, and a lot of distortion appear in the spectra that you obtain, and the transmission data that are normally used to interpret the spectra in infrared can't be used. While Raman and XRD shows no distortion for Raman and XRD, XRD show some shift in the peaks that in any case can be controlled. And varnish is again another problem for FTIR, while it's not a big problem for the other techniques. So you have many different techniques that are available, each one with limitations and with advantages. And here I show some example of the fact that if you apply all together them, you can solve a lot of problems. And in the study of this Portuguese medieval series of manuscripts that belongs to the monastery of Santa Cruz in Portugal, we were able to identify a lot of pigments that characterize the palette of the masters that created the illuminations that were present in the manuscripts that are reported here. You can see lapis and indigo were characterized by Raman, FTIR, and other techniques. Some example, blue, this blue was characterized by XRF to be due to lead, calcium, and minor component. And the lead was due to lead white, as identified by infrared spectroscopy, but also ultramarine blue was detected through the presence of this band that is typical of the CO2 that is trapped inside the beta cage of the mineral lazurite. And ultramarine blue was confirmed by Raman, and also was found the presence of some indigo in this area through the fluorescence observed with this maximum 730 nanometers. Or in this case, for yellow and red tones, mercury and lead were due, as confirmed by Raman, to medium and cinnabar. The yellow, the arsenic was due to the orpiment, and also red dyes were detected using ultraviolet visible fluorescence. And particularly advantageous was this system that was developed inside Charisma that is able to carry out measurements on the same point using a unique optical fiber that then have different ramification. So you observing a unique point, you can carry out measurements in absorption, measurements in emission, and measurements in decay time of the emission. And through these three measurements at the same time on the same point, it was possible to characterize the presence of Mother Lake that in this part of this triptych, here you see, was identified this mixture with azurite on this wing, here in mixture with vermilion on this part of the wing of the angel, here together with azurite again to create this cangiante effect, and here on the face of the angel together with some vermilion. So concerning X-ray diffraction well integrates the result as shown here in this study in Firenze in the Basilica di Santa Croce. These are mural paintings by Agnolo Gaddi. These are the history of the true cross. And these are two measurements, infrared spectroscopy and X-ray diffraction in this zone that is blue, and okay, by FTIR, lapis lazuli was identified through this specific band, and X-ray diffraction confirmed the presence of lazurite. But there were other regions where FTIR was blind, and X-ray diffraction gave results indicating the presence of these yellow areas of lectin yellow type 2 and some goethite. So the integration of the different techniques allowed to obtain several results that are really satisfactory, because where one technique fails, the other can solve the problem. FTIR gives good results concerning the identification of the binding media. Good in the sense that being the measurements non-destructive, you can determine the family of belonging of the binding media. So you can determine if it is a protein or if it is a lipidic binder. Like in this case, this was painted by Raphael by oil, although in some regions the presence of some proteinaceous binder was detected on the blue mantle of the Virgin. Maybe used some proteinaceous binder was used with the first layer of azurite, and then the ultramarine blue was layered there. But also you can detect the family of belonging of binders in contemporary paintings, like in this case, this painting by Alberto Burri, bianco, that means white, it's a monochrome, and you can see that there are different areas that appear flat and other with some rugosity, and we were able carrying out several point measurements all over the surface of the painting, that this area was characterized by the use of vinylic binder, polyvinyl acetate, together with zinc oxide as white pigment, also in this part, and also in this part, while in the other areas, a proteic and lipidic binder was used together with zinc oxide, but also calcium carbonate and barium sulfate. And here is the recognizement of PVA that you can see that is quite well evidenced, this presence, thanks to this band that is the 1370 centimeters to -1, that is due to the CH3 symmetric banding that is not present in the other binders that are commonly used in this kind of paintings, such as the alkydic and acrylic binders. This was PVA, definitely. So what is important to carry out good measurements in situ is the fact that you have to carry out a good work in the laboratory. If you go outside without having prepared the mission, sometimes you can risk to obtain not satisfactory results. And I will show you now a study on the chrome yellows in paintings by Van Gogh, a study that was carried out in our university by Letizia Monico, that carried out the PhD at the University of Perugia in a co-tutoring program with the University of Antwerp. She took 2 degrees. This is possible in Europe. One at the University of Perugia and one in the University of Antwerp. She carried out a study of the chrome yellows pigment that you can see, as shown here in this transparency, in this slide, sorry, can have different tonalities from the orange to the light yellow, and the different tonalities correspond to different composition and also to different crystalline system. Orange chrome is a co-precipitated of lead chromate and lead oxide pigment, and the middle chrome is pure lead chromate in this yellow, and but you have a very white tonalities in case of co-precipitated of lead chromate and lead sulfate together to create a solid solution. And passing from pure lead chromate that is monoclinic, you pass increasing the quantity of the sulfate that is co-precipitated to the orthorhombic system. So Letizia, what these pigments were used by Van Gogh, as mentioned, by letters to Émile Bernard and also to letters to the brother Theo. He is just asking in this letter to the brother Theo to buy the chrome 1, chrome 2, and chrome 3, 3 different types of chrome yellows for him. And so what Letizia did to better characterize the knowledge concerning this pigment was to synthesize different composition, lead chromates, and also those having different crystalline structure. So these are mock samples layered in oil. These are pure lead chromate in the orthorhombic system, pure lead chromate in the monoclinic system, and then co-precipitated with 10%, 25%, 50%, and 75% of sulfates together with chromates. And these are two commercial pigments. This is a commercial pigment, sorry, and this is a mixture, just simply a mixture, not a co-precipitated of chromate and sulfate. And these samples were put in a solar box for 800 hours at 60 degrees centigrade, and what came out from the aging, the artificial aging we did, was that only some of the pigments that were synthesized were subject to alteration. You can see that these three show a definite darkening. And these three are characterized by the presence of the orthorhombic phase, pure lead chromate in the orthorhombic phase, and two co-precipitated with a high quantity of sulfate, higher than 50%, that again are crystallizing in the orthorhombic phase. All the others are maintained intact or apparently similar. And it was possible to characterize through examination at the synchrotron of the various pigments that were alterated, that the alteration consists in a reduction of chromium 6 to chromium 3, with the formation of some chromium oxide that is green, and this explains the darkening, but also some organometal compounds. So, summarizing, the orthorhombic phase is less stable for these pigments, and also those pigments that contain high quantity of sulfates are more subject to the alteration. This called for the monitoring of the presence of this pigment in paintings of Van Gogh, and we were called to the Van Gogh Museum to examine some paintings there, and we took advantage of the fact that we had several models already of different types of pigments with different composition and crystalline structure, and we characterized these substances by FTIR in transmission and in reflectance. That is very important for the Molab. And we characterize also the spectra of these pigments using Raman. And then we moved there, and we were able to find that effectively in this is one of the 6-7 paintings by Van Gogh that we examined there. And it was possible to characterize that indeed here there is one of the pigments that is suspected to be subject to alteration because it contains a large quantity of sulfates, while in this region, for example, there is no risk because the pigment contains a low quantity of sulfates co-precipitated. So the reason that we carried out measurements at the border was due to the fact that here, to carry out measurements by infrared spectroscopy, the restorer that was the user of the Molab removed the varnish to permit to carry out the measurements with more easily. But the results were confirmed by Raman in these two regions, and since Raman do not suffer the presence of the varnish, we carried out measurements also in other parts, and you can see that indeed in other regions like this, here for example, it was found the presence of this lead chromate that is containing a large quantity of sulfate and crystallizing the orthorhombic phase. While in other regions, the yellow-orange was characterized together with some co-precipitated, in mixture with some co-precipitated chromate and sulfate. And also in other parts, the orange pigment was found, the phenylcrocoite, the co-precipitated of chromate and lead oxide. No possibility to sample to verify if there was present there some alteration, but samples were available on other paintings in the archives of the Van Gogh Museum, and measurements at the synchrotron permitted to identify the presence of chromium-3 at the surface of this sample, for example, that showed to be particularly rich in sulfur. So, conclusion for this kind of point investigation: the identification of inorganic pigment can be very good. If you use several different techniques, you can identify almost, I would say, all the various substances that are present on the surface that you are examining. Of course, if you have specific problem, because you want to know layering of different pigments and other things, you need to sample. But if you want to carry out the measurements in order to have a general view, a general overview of the pigments, the palette of the pigments used by the artist, you can do it using simply non-invasive technique in situ. And, or of course, also in the laboratory, if you have the possibility to move the painting in the laboratory. And for concerning the organic substances, the identification is not very good. Let's say it's satisfactory, because you can obtain information on the family of belonging of the binders, proteins, resins, lipids, and you can characterize the nature of the colorants by fluorescence, not in all cases, but with good hopes to be successful. What are the further improvements that can be introduced? The possibility to carry out measurements using portable Raman that excite with excitation in the near infrared. If you use portable Raman with excitation at 1064 nanometer, you can eliminate the fluorescence, the matrix effect, and you can see better colorants, for example. Another possibility is to carry out in situ non-invasive surface-enhanced Raman spectroscopy. This is quite ambitious. There are some activities that are going on. We have recently acquired a spectrometer, a portable spectrometer that works with excitation at 785, but also at 1064 nanometer. And this is a comparison. This is the spectrum of phthalocyanin blue layered in egg with our Molab Raman, and this is using the new Raman with the 164 nanometer excitation. And this is ochre layered in egg, and this is the spectrum obtained using our Raman, the one of the Molab, and this is the spectrum that is obtained using the excitation in the near infrared. Another possibility, so we did not carry out yet measurements using this device, but the hopes to be successful in the future are quite good. The intensity of the signal is lower, but if you have patience and time, at the end the signal is coming out. Another possibility to improve the signal in situ, to characterize organic substances, lakes for example, is to use the SMAArt approach. The idea here is to use a gel of methyl cellulose that has inside the silver nanoparticles. You can put a drop of this gel at the surface of the painting, and then you carry out the measurements, inserts there through the drop. The effect is present. The enhancement factor is not very high, as can be done in the laboratory in more careful conditions, more appropriate, I would say, but a gain of 10 to 4, 10 to 5 is enough to put in evidence the presence of mother lake. This is without the gel, and this is with the gel on the same mock samples. These are all mock samples, no experimentation done in situ. But talking about perspectives, certainly the perspectives belong to the in situ hyperspectral imaging. If we are talking about infrared spectroscopy, we are talking about the possibility to collect distribution of organic substances on a painting. And we are here in Washington, that is a capital, but it's also a capital for the hyperspectral imaging in the infrared. And you can see this work by Paola Ricciardi and John Delany, of course, that they were able, using near-infrared hyperspectral imaging, to characterize the presence of two different binders on this illumination. Egg yolk was used to paint this figure, the figure of the praying prophet, while egg white or Arabic gum was used to paint this green color at the letter of the beginning of this inscription. This was a very interesting results because indicated the use of two different binders in a small illumination, and also the use of egg yolk, that is quite unusual to paint figures in manuscripts, but the author of this painting was Lorenzo Monaco, that was a very good painter in Florence, and there is a painting also here in the National Gallery by Lorenzo Monaco that was used to use evidently egg yolk for his paintings. And we were particularly lucky in our laboratory to have the opportunity to experiment another hyperspectral device, the Brugger H190. These are the technical data of this device. This is a device that Brugger developed for different scopes. And it is applied for the detection of pollutants, organic pollutants in the atmosphere. And they asked us to test the possibility to carry out measurements on artworks using this device. In this case, a lamp in the infrared is needed. You can see this is portable, it's heavy, about 30 kilograms, but can be put on a tripod just in front of the painting at a distance of about 1 meter. The inconvenience, if it is an inconvenient, but it's the fact that the spectral range is quite reduced from 870 up to 1440 centimeters to -1. But we are in the mid-range where it is possible to find some significant bands. And we carried out measurements exploiting the fact that the response of each pixel in the detector is very good in terms of spectra with respect to the Brugger alpha, that is, maybe you know, because it's a portable infrared spectrometer that is not expensive, but is very diffused in the various laboratories. And you can see that the spectra obtained by each different pixel, in each different pixel of the HI19 and the one of Brugger are very similar. And so we are coming back to this painting, Burri, and we were concentrated on this area in our experimentation, this one, where we knew already that here we have polyvinyl acetate, while here we have a proteic and lipidic binder together with other substances and different pigments. And this is a blow-up of the image. The PVA is suspected to be here, and in fact it was detected there. And barium sulfate was detected in this part. No barium sulfate was detected here, but barium sulfate plus gypsum was detected in this part. And in these black points here, gypsum alone was detected. So we learned from this examination that the bumps, the rugosity, was done by gypsum. And this allowed us to understand that Burri created this pigment just taking some gypsum, crashing down it, putting it on the surface, and then putting their glue, covering and maintaining some flat parts, using polyvinyl acetate and zinc white as pigment, and the other part were covered by barium sulfate and other white pigments. So, and this is a summary of what we obtained here. So I want to conclude showing you some numbers concerning Molab. Molab is active in Europe from 2004 because it is operative inside Charisma, but it was operative also before. in another project. And in total, in 10 years, we received in Europe, without excluding the intervention in Italy, inside our country, 152 proposals, 62 proposals were approved, and you can read the numbers there. I put this because I wanted to be sure that if you are not convinced of the quality of the work, at least you should be convinced of the quantity of the work that we have done. Thank you very much.
Thank you so much, Bruno. I think every time I hear about Molab, I'm impressed all over again. I was taking notes. Embedded in your slides are all kinds of little details that pique the interest, which I know you don't have time to go into, but it's just terrific. And I was going to add, but you beat me to it, that I think that if we were to take all of the work that has been generated through Bruno's initiatives here and stacked it up, it would not be portable. So are there questions for Bruno on either, on any of the topics or about the initiatives he has? There's a question in the back, in the middle there.
I can be loud. Okay. So how many applications do you receive annually for projects?
We carry out annually 5 projects in Europe concerning the Perugia laboratory to which I belong. But there are also applications are received by the other laboratories, so a bit more than 5 per year in Europe. Then we received other proposals at the national level. More than 5 is difficult to organize because it is engaging also from a logistic point of view, you can understand. If you go to a museum, for example, there are no problems. If you are going to a monumental site, for example, the things are more complicated because you have to arrange many other things concerning the movement of the instrumentation in the various parts of the monument, work on scaffoldings, these kind of things.
Bruno, you've stunned them. Does anyone have any questions about the miniaturization or the development of the smaller portable instruments? Perhaps actually that would be a long answer, so maybe that can be saved for the for the cocktail hour. Where we but I'm sure much. Bruno will be able to fill in a lot of details that he couldn't cover, but just gave us the overview of, and some very important projects on the stability, deterioration, and understanding preservation of works of art, paintings, and cultural heritage. Thanks,
Thank
Bruno.
You, Barbara. Thank you very much.
Before I hand the podium back over to Chris, I would just like to thank Chris and Tiarna and Austin for putting together a really fascinating program for today. Can't wait for tomorrow. This is very good. So next, I think, though, Francesca is there, and she will come up and talk about some of the important things that she's doing and the new initiative at NU Access.
Thank you, Barbara.
I'll let you introduce yourself.
Yeah. So my name is Francesca Casadillo, and I'm a scientist at the Art Institute of Chicago. And I wanted to take this opportunity today of this wonderful bookends of David Saunders' presentation this morning when he talked about the basic museum toolkit, and he was also very quick to admit that it's not so basic when you're talking about infrared and Raman and all that jazz. And then what Bruno has talked about, which is expanding access to cultural heritage science. Oh, now we have to agree. Just say yes. Where is that? Yes, excellent. Oh, now I have to do it again. Sorry. Let me try again. So thanks to the generosity of the Mellon Foundation, and some of you may know of this initiative, but I thought because we have so many conservators in the audience who may not have this basic toolkit at their disposal, I wanted to just announce again that NU Access exists as an infrastructure that is set up to allow access to expertise and equipment, in part mobile, but we'd have to have a private jet and not a van to sort of reach everyone. But in part, we have mobile facilities, and in part, is fixed laboratories available throughout Northwestern and the Art Institute, where if you have a research question that is important for our field, I encourage you to apply for access. It's free for the users, and we have a call for proposals out April 15th, so I really encourage you to take notice of this web address and then get in contact with either me or Mark Walton, who's our senior scientist, to discuss any project idea that you'd have. But this is definitely a new model that we would like for all of you to be aware of, where maybe you don't have a scientist in-house, but you can definitely access this expertise now also here in the States, and definitely the wonderful work that Bruno and the Molab group have done have been a big inspiration for us. And then if you have 3 more seconds of patience, I'd also would like to advertise the fact that this has been a wonderful, wonderful opportunities where we've heard talks of conservators and scientists, and I really do believe that we want to continue to really have opportunities to meet together and discuss what are the challenges and what are the opportunities in our field to push the envelope for. We've heard things here that we didn't think were possible in terms of imaging and non-invasive analysis, and I really would like to point your attention to the next Gordon Research Conference and Gordon Research Seminar that we're organizing together with Jennifer Maas, who's here in the audience, Philippe Alter, and Tim West, that will take place in Uri, Maine. This summer, and I really encourage you, I know some of you already signed up, thank you, and to propose posters, and we have put together really a wonderful and stimulating program that you see here, and it's really a forum where you're going to hear the most cutting-edge research and where we can formulate these new ideas and try to make possible what seems impossible. So thank you very much for your attention, and if you have questions, I'll be happy to answer those later. And then Tiarna, I think, has some announcement. Oh, Chris.
All right, just a couple closing announcements for today. Thank you all for registering and coming to the conference. Tomorrow, the doors will open much as they did today at 9 o'clock. We'll get underway at 9:30 like we did today. And it's always nice to come to these gatherings as a program coordinator. I am not a conservator. My background is not in conservation or in science. My background is in art history, and so to my expertise, let me tell you a little bit about what will be available at the bar this evening. We'll be going to a restaurant called Cuba Libre. It is very close to the museum. It's about a block and a half away, maybe. It's on the corner of 9th and H. So if you go out the doors that you came in, turn left down to 9th Street, and turn right, and then walk toward H, you'll get there in about 5 or 10 minutes. Because we ended a little bit early, we bumped up our time a little bit. It's about 4:45 now. The reception will start at 5 instead of 5:30. And it will last 2 hours. For the first hour, there will be past hors d'oeuvres and appetizer stations, and sadly, there will be a cash bar, but that's only if you want anything beyond sangria, beer, or wine, or mojitos. So hopefully you won't have to spend too much money. But again, thank you all for coming. See you tomorrow morning at 9 o'clock. And just 2 more points, I'm sorry. If speakers, tomorrow morning session speakers could plan to be here at 8:30 to review presentations, that would be great. And David Saunders, I have your coat. Thank you.